Welcome to Physics Videos. Today's topic is useful ways to express the mass of very small things. The period table of elements is designed so that the mass of 1 mole of carbon-12 is 12 grams. It would be useful to know the mass of a single carbon-12 atom. To do this we need to divide the mass of 1 mole by Avogadro's number. We should convert this mass to the standard mass unit of kilograms. We can go one step further and find the mass of a single carbon-12 nucleus. This means we need to subtract the mass of the electrons in the carbon atom. When we perform the calculation, we find the mass of the nucleus of carbon-12 is 1.9929 times 10 to the minus 26 kilograms. The history of the periodic table leads us to our next step. Since the mass of 1 mole of carbon-12 is 12 grams, we would like to define the mass of one nucleus of carbon-12 to be exactly 12 units as well, so we will define a new unit of mass, called the unified mass unit, so that the mass of this nucleus is 12 units. So, when we divide our previous result by 12, we get that one unified mass unit, the symbol is U, is 1.661 times 10 to the minus 27 kilograms. Now that we have defined the unified mass unit, we can convert the mass of subatomic particles to unified mass units. This should make the values of the masses easier to work with. The mass of a proton becomes 1.007276 mass units. To achieve the level of precision shown in this value, we need to use values for the masses that have more precision than those shown here. We can do similar calculations for the neutron and electron to arrive at the values shown here. Now that we have established a new way to express the mass of very small objects, let's talk about my famous equation that relates mass to energy. You might recall from your previous study that my theory of special relativity predicts that mass and energy are equivalent. They can be related through my equation that states E equals m times c squared. Let's see if we can determine the energy equivalent for one unified mass unit. To do this we will need values with greater precision than we typically write. You can see that these values are much more precise than what we typically work with. To find the energy equivalent, we will substitute the appropriate values into my equation. As you can see, when we substitute the mass of one unified mass unit and the value for the speed of light, we still end up with a very small amount of energy. At least when the energy is expressed as joules. However, we can convert this to a unit of energy that may look more reasonable. You may recall from a previous unit of study that we have defined the electron volt as the energy gained by an electron when accelerated through a potential difference of 1 volt. Substituting our most precise value for E, the charge of an electron, we can express an electron volt in units of joules. With this conversion, we can write the energy associated with one unified mass unit in electron volts. Now, let's recap what we've done so far. We defined the unified mass unit as 1/12 of the mass of the nucleus of carbon-12. Then, we determined the energy equivalent of this mass in joules and converted it to electron volts. Looking at this result, there is one more innovation that we can make in terms of describing the mass of an object. As you can see, if we symbolically divide both sides of the result by c squared, the value doesn't change. However, we have defined a new unit of mass designed specifically for use with my mass-energy equation. Let's take a look at the mass of some subatomic particles, expressed in this new unit. Here are the different values for the mass of a proton, expressed in the new units we have defined. Notice how similar the mass of a neutron is to the mass of a proton. They are almost the same, but not exactly the same. And finally, we see that in these new units the mass of an electron has a value that is easier to work with. Your instructor will now show you what we can do with all of this new information. This is the end of the video, as we say in German.
Auf Wiedersehen.